Hello everyone, dear friends. Our ancestors believed that if you look through the ears of a horse, you can see a goblin. And let it be such a high-tech detector. But the essence remains the same. With this simple device, our ancestors tried to see what the human eye cannot see without special devices. Time goes by, everything changes, and today I'm holding a very ordinary smartphone with a camera in my hands. Well, with the help of a mobile phone camera, you can also see a lot of interesting things. Today we will talk about 3 interesting cases when you can see something unusual using a mobile phone camera. Well, as before, Yuri Trifonov is with you. If you like the video, of course, subscribe, share, tell your friends. But let's get started. There is a lot of that around us, what we don't see. But it seems like there are the same radio waves and the same radiation, ultraviolet radiation of DP and a lot of other interesting things. In order to see this, a person needs to use special devices and in exactly the same way as the horse's ears were used before. If you believe the signs, of course, special detectors are used. For example, radiation is measured using a radiation detector, or ultraviolet radiation is measured by special scanners. But in order to, you don't have to have a scanner to see this. With the help of a smartphone camera, we will be able to see other interesting things that exist around us and that cannot be seen with a simple eye. And if you remember one of the first videos, it's a video about how an incandescent light bulb works. The most ordinary good old sweetheart that was invented by Edison, remember, and watch this video. There we said that the light bulb is capable of flickering. Why is the light bulb flickering? Because that we have alternating current in the network. Alternating current is such a thing when our current value is constantly changing. There is a certain amplitude and the current varies along the sine wave, reaching their values. The current changes the value and there are times when there is no current at all. And, to put it very simply, we take the most ordinary gas discharge lamp. How does it work? Roughly speaking, an electric discharge is breaking through. The gas inside the lamp is ignited according to these pulses and in accordance with the amplitudes. The gas starts to glow. It lights up and goes out, but the eye does not see it well. It is obvious that the gas will be ignited in accordance with the current parameters. Very fast and invisible. But if we take the phone's camera, switch to video, and the video will flicker noticeably if the exposure is set correctly. Good light bulbs practically do not flicker, because such flickers spoil vision and cause unpleasant sensations. The light bulb is flickering. The flicker frequency of such bulbs is usually 100 to 120 Hz, about twice as much as, in fact, the frequency of the current in the network from which it is powered. Flickering can be seen with the help of a mobile phone camera, although new models correct this phenomenon. Why are these running stripes visible? How does the camera show them? The camera does not actually shoot video, but a lot of photos that are glued together. From a large number of frames are connected streams, and then it turns out how they will show us at animation workshops. When we have a cartoon going from frame to frame, the same picture is obtained on the video camera. And if these frames are taken at a low frequency, then this is exactly the number of frames per second. This is the basis, so if it turns out that the light bulb is repeatedly photographed and, depending on its condition, the frame will be light or dark, such states change per unit of time. It turns out a lot of dark and light frames. As a result, we will see the flicker of a light bulb, which our eyes just doesn't have time to capture it, but our body reacts to it anyway. From here, you can get into such a frequency that it will be, at least, unpleasant. Therefore, if the frequencies of the video camera and the lamp do not match, then flickering will be visible on the rollers. With the help of this simple decoder, in fact, almost like through the ears of a horse, we see how the light bulb flickers. If you read how the brightness of the well-known smartphones changes today, then you will find out that there is no change in brightness. The screen itself and the number of pulsations changes. We have the same scheme. What is light anyway? Well, roughly it's a stream, let's just say particles, a stream of photons. However, there is a whole story there and we will not delve into this topic now. One can argue about the nature of the photon itself for a long time, but this is not the very purpose of the conversation. Something else is important. The light has a certain amount. The amount of light can be changed as by making a source less bright, and by changing the number of pulses that are sent. And any screen, even the camera screen that I'm looking at now when I'm shooting, the TV screen, the computer screen, does a certain amount of flickering in time or per unit of time. This is controlled in a modern display by a control circuit that directs the required number of pulses to these LEDs. And if you do it right and well, then you need to make the LEDs themselves change brightness. How? Say, we can now use a rheostat to change the brightness of an ordinary light bulb. That's the same way, in theory, you need to actually change the brightness of the screen with the help of a rheostat. The scheme will of course be more complicated, but the cunning manufacturers went the smarter way. They simplified the scheme and began to limit the brightness to the amount of light that we will eventually see, which is simpler, but definitely not more useful. But, in general, for you and me, if you put aside all the harmful and unpleasant moments, it's like changing the brightness of the system. This may be a rheostat, which limits the number of pulses or flashes of light per unit of time. The only difference is that if, instead of actually reducing the brightness, you change the number of flashes, then gadgets make your eyes hurt and fatigue begins to appear. And why is this happening? Because in order to limit the brightness of the screen, fewer flashes are used, and as a result, we have that with high brightness from such a screen, the eyes do not get tired, and with low brightness, when the number of flashes of the screen becomes if the body registers this, the eyes get tired. And this very process can be perfectly seen using another mobile phone or camera. We point our camera at the screen of a phone or smartphone, or any other device with the camera and see a kind of interesting flicker. Usually, the frequency of this flicker is so high that our phone is not able to capture it fully. Therefore, the effect of flickering will look like stripes or ripples on the screen. But if you have seen this, then, to put it mildly, it is not very good. The next interesting thing that can be seen using a smartphone camera is various kinds of radiation. Here you can immediately recall a bunch of different detectors that already exist. These are all sorts of different thermal imagers or night vision devices. You can't see it with your eyes either. There are devices that can literally see through walls. They work on the principle that they detect radiation that we do not see, for example, as infrared radiation. Let's remember the nature of light. There was a whole video about it. Light has a visible range. The visible range has a definite wavelength. We don't see infrared radiation, but a bat can perfectly see infrared radiation. But if you take a special device thanks to which you can see the infrared light, we see a glow. Let's see how the warm animals that hide in the dark forest glow. It's quite interesting. And by the way, I really wanted to buy myself such a device so that I could walk through the forest in the evenings and see the different animals that are there. Well, our mobile phone with its camera can perfectly see infrared radiation sometimes. The sensitivity range of the matrix is extended. When we look at some source that we don't see with our eyes, the phone records this source. The camera actually converts it to the wavelength that we can see. The system will show a picture on the screen. Take a look at the frame that I am bringing, and you will see that the sensor is glowing. Here at this receipt printer we have a sensor in infrared light. It is needed in order to find a gap in the tape. If you look at this sensor with your eyes, then we don't see its glow eyes without special devices. If you look at this sensor through the camera of your mobile phone, we will see an interesting red-purple glow. This will be the infrared light. By the way, again, it is better not to play with such radiation, since its exact wavelength is unknown and it is unclear how it will affect the eyes. Therefore, it is not necessary to shine in the eyes, even taking into account the fact that you don't see its obvious glow. There are even high-power lasers that are not visible, but can damage the eyes. You can also see that the radiation on the scanner varies depending on the operating cycle of the device. It glows with a bright white light when the scan is taking place, and then it glows green and mark. The green light does not see the eyes. This green light is visible only in the camera. Maybe even as a result, the ideas of our ancestors about horse ears when searching for forest creatures will somehow literally be confirmed. Maybe there are some, I don't know, clumps of energy, or you never know what it might be. Anyway, if you have a device that can fix it, then maybe we can explain it. Well, for this issue, I think there is quite enough information. Thank you all for watching. We subscribe and like it.